Okay, let's start with this week's session. In the last week, we saw a very basic overview on Python and some of the data types that are available with Python. And now we're going to go into much details in those data types. Okay, so let's start with list. Okay, we are going to use it a lot. So a list, uh, it is actually similar to a 1D array in MATLAB. Okay, so let's come here. Okay. Say for example, I am creating a list. Okay, so as you can see, this is the console or kernel, and here you can see the variables. If you go to the variable explorer, you can see the values. Okay, so as well as the type and the name. Okay, so this name A, this is a list of size 3, and this is the value. Okay, so we'll try to keep a look at here when you do something what actually happens here. That will actually make things much more easier. Okay, acha. So if we start now. Okay, so the first thing that we are going to see is called slicing. Okay, slicing. You are familiar with the concept of index in Python from the last class. So you know that the first element is indexed as 0, the second element is indexed as 1, and the third element is indexed as 2. This is a different because Python works with zero indexing. So if I write something like this way, a of 0, okay, so this is going to return the first element, and as you can see, we used these square brackets to do the indexing. Okay, so here slicing, first of all we use this square brackets. Okay, it is unlike MATLAB, so that is one thing, and it starts from 0 index, and we can also look at the last element using the negative index. Okay, these two things are shown in the last class. Now say if I want to do something different, say for example I want the first two elements. Okay, directly if I want the first two elements, I can do like this way: a of, okay, 0, that means first element, is to 1. Okay, now this may look that, okay, first element to the second element, but this is going to return something different. Okay, as you can see, this is returning only 4. The second element, that is 7, is not returned here. The reason is that Python actually, it is called upper bound exclusive. When you are slicing, it is called upper bound exclusive. Okay, what does that mean? It means that, say for example, if I do something like this, a of 2 is to, say for example, 2 is to 5. Okay, so it will include this element. It will include 2, index 2, index 3, index 4, but it will not include index 5. Okay, the index 5 will be excluded. That's called upper bound exclusive, so we will not consider that. Okay, so say for example, if I want the first two elements, I have to write something like this: 0 is to 2. That means the index from a of 0 and a of 1 both will be given, but a of 2 will not be given. So that is how we have 4, 7. Okay, so let me write yet another list. A bit longer. So this is another list with 7 elements. Say for example, I want this 3, 209. So I will see 0, 1, 2. This is the second index. So b of, start from second index to 2, 3, 4. So I have to write 5. Okay, so a little bit practice is required to actually get familiar with this thing. Okay, now say for example, I want from this position, I want all the elements that are there, okay, to the end. So I can do something like this: b of 2 is 2. Okay, I don't place anything there, so it will return all the elements up to the end. Okay, so this is one way. And say for example, I want all the elements from start to this position, so I will write all the rows all up to 3, because if I don't, okay, so 1, 3, 2. Okay, so this is the way of actually slicing a particular portion from a list. Now one other thing we can do, say for example, if I write like this way, 2 is to minus 1. So can you guess what is the output? Okay, so it will exclude the last element like this way. You can also use positive indexing and negative indexing altogether. Okay, so I hope this is clear. And one other thing, if you want to extract all the elements, I will just write something like this way, b of all. So this is return all the elements in the matrix, okay, in the list. Okay, so this is about slicing. So this is about slicing. Now let's come here. So changing item. Okay, so say for example, I want to change a particular item in the list. Okay, so say for example, I want to change this one. Okay, so I will write b of 1. I'll just assign a value to it. So for example, b of 1 is equals to, say for example, a. Okay, so as you can see, when I write this thing in the original list, this b, the element in the second index is changed. Okay, so using this, I am using the index to change a particular element. Okay, so this way you can change the particular value from a list. Okay, now you can also actually change multiple elements at a single time. Say for example, from 2 is to 5, that means 2 is to 4, I am to change it to bbb. Okay, okay, now as you can see, 2 3 4, there are 3 elements. All the three elements actually changed into like this way. Now let's do something different. Now as you can see, if I give only one element, okay, from 5 is to n, the size of the list has decreased. Okay, all the 2 elements that were there has been changed into c. Okay, so this way you can actually modify items, okay, change the values of the items from a list. Okay, so this is the second thing. Now okay, so what if we want to actually check whether an item actually in the list? Okay, there are something that is called is member. Okay, things like that we actually used in MATLAB. So there is something different that is called, say for example, I check AAA in B is the list. If I write like this way, this in of, okay, in, this is a built-in function. If I write this way, it is going to return me either true or false. Okay, this is a very simple thing, whether this element, this one, is in that list. Say for example, if I write 3 4 in B, as you can see, 4 is not within our list, so 4, it is giving me false. So this in operation is one thing, and there is another thing that is called not in. Okay, this is exactly the opposite thing. It is going to give me true because this is 4 is not in B. So if I want to check an item whether it exists in the list or not, I can use in or not in. Okay, these two options are there. Okay. Now let's go further. So this is actually what we can I'm just showing you what you can do with list. Okay, and since Python actually is a bit different than MATLAB, so you need to practice a little bit actually to get yourself familiar with these things. Okay, so let's say I want to remove an item. Okay, delete an item, remove an item from a list. Okay, so to remove an item, okay, so I have to write something like this: del, this is a built-in function in Python, del, say for example p of 0, I want to delete that item. Okay, as you can see, when I delete it, okay, you can check here in the variable explorer, that value is gone, the first item is gone. Say for example, I want to delete the last item, I will write del of b of last item. Okay, as you can see, the last item is also gone. Okay, so this del is used to delete a particular item from a list. So to remove an item, I will use del, okay, b of, this is the index. Okay, now one other thing that is something previously in MATLAB, we used to do something like this in MATLAB. we used to write that, say for example, a of 3 is equals to null. Okay, this empty array, if I do this like this way, that element will be removed, something like this. But say for example, if I want to do that here, say b of 2, okay, b of 2 is equals to as you can see, the second element is actually changed into an empty list. Okay, that means that this empty list is considered as an item. Okay, it does not delete any element from the array, from the list. Okay, it is considered as an item of the list because this is a heterogeneous type. So a list, okay, an item, integer value or a string or everything will be considered as an item from the list. Okay, so I believe it is, I hope it is clear. Okay, so this is another way to do this. Now okay, now let's try to understand one thing. Concentrate a little bit here. Say for example, broadcasting is not possible. Okay, so I actually mentioned that in the last class as well. Let's take a look. In MATLAB we used to say, for example, I have something like this. If I have something like this, say 2,3, okay, if I actually add something, if I add, say for example, +5, if I do something like that, what will happen? This 5 will be added to both the element, to this element and this element, and the output will be like 7 and 8. Okay, this is the concept of broadcasting. Okay, that is actually implemented in MATLAB. Okay, this element will create a replica and add all together because this is like a matrix. But Python, that will not happen. If you try to take a look here, so our original a was like this. Say for example, if I write a plus 5, as you can see, can only concatenate list to list. Okay, so adding an element like this where broadcasting is not possible with the basic Python list. Okay, the list data type does not allow this. Okay, NumPy array allow this, but the list does not. So this way, the broadcasting is not actually possible with that way. But we can do something, as you can see, it is written here, concatenate list. So if I do like this way, a plus 5, okay, as you can see, 5 will be added to the list. Okay, if I like this, make the 5 as list, okay, then 5 will be added as an element to the list. But check here, our original array is not changed. Okay, I have to do the assignment operation. Say c is equals to a plus 5, like this way. Only then I have a new list. Original list is not changed, but the new list has a new element 5. Okay, so I hope it is clear. So I can, this is called catenation. Okay, using the plus sign. Okay, using the plus sign, catenation. Okay, using the plus sign that was used to do broadcasting in MATLAB, and that is actually like a catenation operator in Python.